Okay, now it's time for another demo. Let me show you how to launch an RCE attack via deserialization in Java. So what I've got here is a testing web application, and now I'm gonna click this button, training registration, date 2nd December 2022, and I'm going to intercept the request going out from my browser. So let me first turn on the interceptor. As you already know, I'm using Burp Suite proxy in my testing lab environment. I'm gonna click this button, and here is my intercepted request. As you can see, the registration date is sent in the get parameter named date, and it seems to be base 64 encoded, right? So let me take it right now. Let me copy this and let me go to the decoder right now. The very nice functionality of Burp Suite is that there is also a decoder, not only a proxy, but also a decoder and other functionalities as well. But in decoder, I can just paste my data, and I can encode the data, decode the data, a lot of different options. So I have taken this data from the URL, so I'm gonna first decode it as URL, and then I'm gonna decode it as base 64 because I recognize this structure, right? Base 64 encoded data. Okay, so what I can see here is that, well, it looks like a serialized object in Java. Please take a look here. The class is Java Beans XML decoder, and as I told you in the previous video, this class is used for serialization in Java. And our data, so the registration date, actually is sent out there. So we've got the day is, you see here, 2nd, and later on we've got the month, right? You see the month here, it's 12, and later on we shall have a year, right? Yeah, we've got a year, 2022. But the most important point is that, well, this is a serialized object in Java, which is really cool for us because right now we are going to use the knowledge from the previous video, and we are going to launch RCE via deserialization. We are going to establish a reverse shell connection, and yeah, I'm gonna show you how it works. Okay, so let me maybe first go here. Here is my malicious serialized object. This is exactly what I presented to you in the previous video. So we've got reverse shell connection, but this time to localhost 1111. And as I explained to you in the previous video, we need a class that allows us to launch a shell command. And for this purpose, we are going to use groovy-lang groovy shell. And once this class is loaded in the class path, then we can use it to execute our command. And our command, as I mentioned, is about establishing a remote shell connection to localhost port 1111. I've got a testing lab environment, and I don't need necessarily to create reverse shell connection to external machine. Of course, in reality, this is how it works when you do a normal testing, let's say, but this is just a training, and I'm gonna show you everything on my one self-contained testing environment, okay? So you see, I'm gonna connect to localhost 1111 as a result of the reverse shell connection, right? So I'm gonna first listen on that port on my local machine, right? So I'm going to use nc-v-l-p1111. This is the command that I'm going to, launch in order to listen on this port. Now I'm listening on this port on localhost. And yeah, the next step is like this. This is my serialized object. actually malicious serialized object in Java. So I'm gonna take this object, I'm gonna copy it. Let's go back to burp. I can just delete everything from here. I'm gonna paste it. Now, keep in mind, let's go to the proxy, that my serialized object is sent in the date parameter, and this is base64 encoded, right? So what I have to do with my malicious serialized object is I have to encode it to base64, right? Now let's analyze if there are any special characters. In other words, do we have to URL encode this data or not? Yeah, there is, for example, plus. Plus has a special meaning in the URL. Yeah, we can actually take the entire data here and we can encode it to the URL. We can either, a URL encode special characters like pluses here, or we can just URL encode everything and then the problem is solved, okay? So yeah, this is URL encoded version. Now I'm gonna take this guy, I'm gonna copy it, and I'm gonna go to the proxy. Keep in mind that all the time here, I have the intercepted request from my browser, right? But before sending the legitimate serialized object to the web application, I'm gonna replace it with malicious serialized object. Of course, base64 encoded, because this is how this web application works, okay? So I'm gonna paste it here, okay? I believe that this is clear for you. And now I'm gonna send this request to the web application. Let's do it. Let's see how the web application responds. Something went wrong, sorry. GroovyLang Groovy Shell cannot be cast to date. Well, this is funny because, the web application expects the date, right? Because we are going to register for a training for a given date. And instead of sending the date, we are sending our own malicious serialized object. We are using GroovyLang Groovy Shell. So, indeed, GroovyLang Groovy Shell cannot be cast to date, but it's not a problem, because when you send the serialized data to the web application, then what's going to happen is like this. First, the data is deserialized, and then the web application is trying to do something with this stuff. And the web application cannot do anything with this stuff because GroovyLang Groovy Shell cannot be cast to date, but it has already been deserialized. As a result of deserialization, my own code, so the reverse shell connection, has been executed. I will show you in a minute. And now I don't care that one cannot be cast to another, right? So keep in mind, we've got deserialization. As a result of deserialization, we've got actually remote code execution. And then I don't care that one cannot be cast to another. So I don't care that GroovyLang Groovy Shell cannot be cast to date because it happens after the remote code execution, right? So I don't care about it. My code has already been executed as a result of deserialization. I don't have to bother about processing of this data later on, right? By the web application. I believe that this is clear for you. So now let me go to the console, and what I can see is that indeed something has changed here. You see information about the connection. Well, the connection has been established as a result of this deserialization. But now let me show you that indeed it works, and you can do whatever you want on a vulnerable machine. So let me provide, for example, uname-a. You see the information about the Linux version, right? What else can I do? I can, for example, do cat etc pass wd. Why not? I can do whatever I want. I've got established a reverse shell connection with a vulnerable machine, and now I can do whatever I want. I can list the files in the directory, whatever, right? So whatever comes up to your mind can be right now executed. Reverse shell connection has been established. That's great. So you see that deserialization can be really dangerous. And on the other hand, it can be really powerful in the hands of the hacker. So as you can see, indeed, remote code execution via deserialization is possible. It's really powerful. Right now, we've got a reverse shell connection. We can do whatever we want. It's just brilliant. So yeah, this is how it works. I believe that this is right now clear for you, and I believe that you really like it. So that's it for this demo, and let me right now jump to the next video.